Welcome to our video today, where we're going to explore one of the most common pain points in .IO. Net development why QueueUserWorkItem can be slow to start. If you've worked with threading or asynchronous programming in .NET, chances are you've stumbled upon this issue at some point. In this video, we'll delve into the reasons behind this slowness and provide a clear explanation of what's happening under the hood. Whether you're a seasoned developer or just starting out, understanding how QueueUserWorkItem works is crucial for building efficient and scalable applications. So let's dive in and find out why this method can be slow to start. So what exactly is QueueUserWorkItem? And why does it seem to take its time to get started? To answer this question, we need to take a step back and look at the underlying mechanics of .NET's threading model. When you call QueueUserWorkItem, you're essentially asking the runtime to execute a piece of code on a thread pool thread. However, before that can happen, the runtime needs to find an available thread in the pool or create a new one if none are idle. This process is called thread injection. It's during this thread injection phase that things can slow down. Here's what happens when you queue a work item. The runtime checks the current load on the system and decides whether to inject a new thread into the pool or use an existing idle thread. If the system is under heavy load, it might take some time for the runtime to determine the best course of action. Imagine it like trying to hail a taxi during rush hour. You put up your hand, but it takes a few minutes for an available taxi to pull over and pick you up. That's roughly what's happening with thread injection. The system is waiting for the right moment to pick up your work item and execute it. Another important factor at play here is the concept of thread starvation. This occurs when one or more threads in the pool are blocked, preventing other threads from executing. It's like having a taxi stuck in traffic. Even though there are available taxis on the road, they can't move because of congestion. In .NET, thread starvation can happen due to various reasons, such as long-running database queries, network calls, or even just plain old CPU-intensive computations. When this happens, your queued work item has to wait for these blocked threads to free up before it can be executed. To recap, the slowness of QueueUserWorkItem can be attributed to two main factors: thread injection and thread starvation. The runtime needs time to determine whether to inject a new thread into the pool or use an existing idle thread, especially under heavy system load. Additionally, thread starvation caused by blocked threads in the pool can prevent your work item from being executed promptly. Understanding these concepts is crucial for building efficient and scalable applications that make effective use of .NET's threading capabilities. That's all for today's video on why QueueUserWorkItem can be slow to start. We hope you now have a better understanding of the underlying mechanics at play here. If you have any questions or topics you'd like us to cover in future videos, please leave them in the comments below. Don't forget to like this video and subscribe to our channel for more content on .NET development and related topics. Your feedback is invaluable in helping us create better content for you. Thanks for watching.